What exactly is an Epson chip? The Epson patent describes the chip as a semiconductor memory device storing information related to ink mounted on the ink cartridge near the gold contacts. The purposes of these chips is to prevent cartridge reuse or refilling and lock out non-Epson ink cartridges. Once the ink level is read as empty, the chip disables itself and the printer will reject that ink cartridge permanently. The chip is not connected with any sensor that detects the amount of ink remaining, but it estimates the ink remaining based on usage data from previous print. Here's a deeper look at how the Epson chip works. These chips are not just a counter. The chip is a very small EEPROMs, an electrically erasable memory. The memory of the chip is very small, often just a few hundred bytes. 128, maximum 512 byte. The memory structure of the chip is a sequence of byte. Like this. Layouts vary, but this structure is consistent with many findings. Now we will decode it. The values A210 identify the manufacturer, Epson. 4F23 identify the model ID of the chip. 71 is the cartridge family. For example, T071 series. If it doesn't match, the printer rejects the cartridge. This is the color code. 11 could be black, 12 could be cyan, and so on. It prevents you from inserting the cartridge into the wrong color slot, as cartridges are often the same. This is the region code. 0000 could be Europe, 0001 Asia, and so on. The cartridges are locked to geographic market. A cartridge purchased in the United States may not work in a European printer, and if you purchase a printer in Asia, the cartridge will not be accepted by European printers. 08 is the unique identification serial number and the batch number. Every cartridge has a different serial number. It prevents simple refilling reuse, since the printer remembers the serial number of the cartridge. Compatible cartridges sometimes use the same ID ranges in all their cartridges. Epson definitely monitors compatible cartridges. When Epson detects an ID number used by a compatible cartridge manufacturer, it performs a firmware update, causing the printer to flag all chips with that ID as invalid. Address 10 is the ink level. 64 means 100%. This is the core of the system. An EEPROM has limited write cycles, so ink level counter is stored as a simple number. For example 64 to 0, where 64 is full and 0 is empty or similar scale. Important. This is purely algorithmic, not sensor-based. The ink level is not measured physically. The chip is not connected with any ink sensor. Instead, it calculates usage based on printing activity. Decrements are based on the number of printed pages and page coverage. For example, a photo might take up 50% of the page, while text might take up 5% to 10%, so a page of text will decrement the counter less. Cleaning cycles consume a lot of ink. But, since the chip has no way to detect the exact amount of consumed ink, the chip assigns a quite high penalty every time you perform a cleaning cycle. Once the counter hits 0, the cartridge is considered unusable, even if there's still ink inside. The printer trusts the chip more than reality. Epson's theory is that if at least a small amount of ink isn't left, the printhead could be damaged. However, there is also a glass window under the ink cartridge that detects the presence of ink inside the cartridge, but it is not connected to the chip and it is only for safety, as the chip always blocks the cartridge much earlier. In some models, chips keep track of the number of ink drops ejected by the printhead. Address 12 is the status flag. The flag is more important than the counter. The flags are: bit 0 is empty flag. When ink value reaches 0, that cartridge is flagged as empty, and that cartridge is dead. It is irreversible. Bit 1 is first use flag. It sets when cartridge is installed the first time. It prevents the reuse of that cartridge in another printer. Bit 2 is valid authentication flag. It indicates that the chip passed initial check. Bit 3 is error flag. Corruption, communication issues, or a compatible cartridge not recognized. This value is permanent. So once the cartridge has this flag, it will be always rejected. This is why an ink cartridge, once it receives the cartridge not recognized error message, can no longer be used. A new cartridge will have all zeros, meaning it is not empty, not used yet, and no errors. This cartridge, for example, would be recognized as valid, all read in use, but permanently empty. 20 is the checksum, in this case 3B7C. Shortly, it is used to check the cartridge. More precisely, the printer make a CRC, cyclic redundancy check. That is a robust algorithm that detects data changes. If checksum fails, mostly in case of compatible cartridges, the cartridge is rejected. It is not so easy to pass the check because Epson doesn't usually leave data raw. The data are obfuscated or encoded, stored non-linearly, subject to mathematical operations as XOR to check them. It is not a strong encryption. EPROMs contains few datas and have low voltage, 3-5 volt. Newer Epson chips are a harder target because they could require challenge response authentication. The printer sends a challenge. The chip must compute a response using a secret key. The chip communicates with the printer via a serial interface in the electronic contacts, using a proprietary serial protocol, very similar to I superscript 2C, but not identical. Conclusions: the chip doesn't measure ink. It only enforces usage policy. We can therefore say that when you buy a cartridge, you are not buying ink, but rather the right to print a certain number of copies, a sort of cost per page contract. The chip is purely passive memory. The intelligence is in the firmware of the printer, not the chip of the cartridge. It is the printer and not the chip that calculates usage and writes updated value back to chip. The best way to trick the Epson chip is therefore to install new firmware, such as the Inkchip one, which is designed to ignore data coming from the chip. The Inkchip website is in the description.